I want to thank all the professors, but particularly Professor Guangju Zhao. He really made an effort to provide us the perspective of soil and water conservation in China. And unfortunately, he couldn't come, but he will be hopefully the next opportunity that we could travel across continents. And now Professor Guangju is going to give a perspective of soil and water conservation in China. So Guangju, the floor is yours.
Yeah, okay. So thank you very much for Professor Gómez to give an introduction, and also I'm really happy and honored to be invited by Professor Gómez in this such international cooperation groups and also with this workshop. So today I will spend maybe less than 1 hour to give an introduction about soil and water conservation in China. And here, firstly, it's a good opportunity to introduce our progresses in soil and water conservation, and also experience and achievements to different countries. And we also want to you to know that what we have done. So first, this is the outline of my introduction. We have 4 parts. The first part is the introduction of the institute, of my institute. And the second and the third part is the general introduction of soil and water laws in China, and also our achievements and experience of soil and water conservation. And finally, I would like to give a case study on the Lewis Plateau, where it is seriously eroded. So let's go to the first part. So I would like to give a short introduction about our institute. So you can see the figures that here we have, this is where I am located. It's very close to the middle part of China in Xi'an city. And the city Xi'an is a very long history, with be very famous because of the Terracotta Museum. And also in this region, we have very flat area making different kinds of noodles. And Yangling is my working place. We have very limited population here, and only including one university. It's called the Northwest and Agricultural University. I'm now working in the Institute of Soil and Water Conservation. And this is the history of the institute. So this is our institute is the first institute for soil and water conservation in China, and to reduce the soil erosion and sediment yield to the Yellow River. So our institute was built in 1950s. And then in 1956, it becomes to the Northwest Institute of Agriculture and Biology, and from Chinese Academy of Science. And afterwards, it became Northwest Institute about biology, pathology, and afterwards, some of our colleagues go to Xi'an and to build the botanical garden. And the remaining groups continue to work in the institute. And the topic may change due to the national requirements. And the big change is around 2000. So in 2000 around, we have different affiliations that belong to Chinese Academy of Science and the Ministry for Water Resources, and also our institute become a part of Northwest Agriculture and University. And some of our friends, Peter and Gómez, didn't come, but Peter come here, I think several times. Our institute includes several parts. First is 5 national units. It's about a key laboratory of soil rain and dryland farming on the Lewis Plateau, and also national engineering for crop water use efficiency. and the National Engineering Technology Research Center for Water Saving and Irrigation. Also, we have 2 national soil and water conservation stations. And we also have provincial units like Engineering and Technology Center, and also K-Lab for water saving, and Modern Water Saving Irrigation Center, also a field station here. And you can see here, we have different research platforms. In the left upper part, we have a rainfall simulation hall, and it provides quite a lot of runoff plots for simulate different rainfall intensity and rainfall amounts and different slopes. And so we can do the rainfall simulations. And also we have a dryland farming hall that was doing different plantation and also water stress limitations simulation. And also we have some field station like here. We get a dryland farming and water saving and irrigation systems. And on the Louis Plateau, we have, during the past several decades, we have constructed ecological stations like Ansai here, and Yangling is here. Our location is here, and we have Changwu, Ansai, and Shenmu, Mizhi, and also Guyuan, different regions for soil and water conservation. So in the past around several decades, what we have done. So first we propose, our colleagues and different groups proposing the classification systems for soil types for China. And also we did quite a lot of experimental research on soil and water conservation, also field monitoring stations and indoor simulation. And we also developed a Chinese soil loss equation erosion model and based on USLE that was developed in the United States. And we also do the benefits assessment of soil and water conservation. And in the Louis Plateau, we have relatively limited rainfall, and so there are some works have been done for efficient use of soil, water, and nutrients for arid agriculture system. And we also developing the SPARK model to understanding the response of plants or crops to water, different water stress. And finally, we also developing high water use efficient technology like irrigation technologies. We also communicate with many countries, and we did quite a lot of cooperation with many groups. And now I have been invited by this free program, and I'm one of the partners in the free program. This is really good groups that cooperate between EU countries and China, and we have different parties around China and contribute to the same topic. And also, during the past years, we have cooperation with the United States, Germany, and Japan, Spain, and Korea, England. We have quite a lot of cooperation projects related to soil and water conservation and dryland farming, irrigation, agriculture, ecosystem, and ecological restoration. And we also organize quite many international symposiums and workshops. And currently, our research topic is, one is soil and water conservation, and the other one is the ecology restoration and the applications in integrated land. So we do the theoretical analysis and the model development for soil rain, and also including arid agriculture, water saving and irrigations. And we also now developing the engineering technologies of soil and water conservation. And now on the Louis Plateau, it's really degraded, and we do around 30 years for ecological restoration, like afforestation, grassing, and planting quite a lot of trees. And finally, it's about soil functions improvement and restoration. So the second part is about soil and water use in China. Probably some of you may visit in China several years ago, and China has a large territory, around 9.6 million square kilometers. And in the right part, we show a map of land use. You can see here in the east part of China, in the flat plain, we have arable land and the forest land distributed in the northern China and also southern China and also southeast China and South China. And grassland distributed widely, mostly in northern Inner Mongolia and the Xinjiang region and also Tibet region. So we have also different sparsely distributed in the southern part. And this figure shows the proportion of different land use map, different use. You can see forest land contribute 16% and arable land contribute 14%. And grassland contributes 29%, and water and the urban area contributes respectively around 3%. But we still have around 35% that was desert region and also high mountains without vegetations. So there are around 30%, more than 30% that was not used. And China has a very complex natural environment. This very high spatial heterogeneity in climate, topography, the soil, and the landscape. About 67% of the entire territory constitutes mountains and hills. So there are around 60% we can't use successfully. And this is, in China, we cross very large scale, and we have multiple climate zones, including tropical, subtropical. This is located in South China. And here we have warm, temperate, and moderate temperate climate. And in the Tibet and in the northern China, we have very cold regions. So the land area affected by the soil rain was around 3.5 million square kilometers. That was around 40% of our country. So this shows the soil erosion map and different soil erosion influenced. The national map of the soil erosion shows that here in the northern part and also in this desert was influenced by wind erosion. And in the southern part, in the east part, we have the water erosion region. And in the Tibet region, we have freezing and melting erosion. So in generally, China is one of the countries suffering from serious soil erosion with different erosion types. And it was characterized by widely distributed large area with erosion regions and different soil erosion forcings like wind and water and frozen. And we have very serious soil loss and high sediment yields to the rivers. This is the contribution of a different proportion. You can see here, water erosion contributes 1.65 million square kilometers, and the wind erosion is around 1.9 million square kilometers. And there are some regions that was around 0.26 caused by both water and wind erosion. So we classified the erosion regions with different intensity, like a slight was less than 2,500, and the moderate is 2,500 to 5,100, 10 per square meter per year. And strong belong to 5,000 to 8,000, and the very strong is around 8 to 15,000, 10 per square kilometers per year. So By the statistic, we know that in our country we have 45% belong to the slight irrigation region, and 23% belong to the moderate irrigation region, and 12% belong to the strong irrigation region, and very strong regions accounted for 9%, and 11% accounted for 11%. So these figures show the Chinese irrigation figures. And China loses about 4.5 billion tons of soil each year, accounting for about 17% of the world. But now it's becoming better. The annual loss for the Yangtze River, we have two large rivers, Yangtze River and the Yellow River. So I'm located in the Yellow River Basin. And the Yellow River Basin receives an average of 1.6 billion tons of sediment each year, leading to sedimentation in the downstream of the riverbank. And we have quite a lot of different types of water and soil with different regions. And the water irrigation is mainly concentrated or distributed in the Yangtze River and the Yellow River Basin, accounted for 60% of water irrigation area. And wind irrigation is mainly distributed in the northwest China, in the Mongolia and the northeast China, accounted for more than 99% of the total wind irrigation region. And the soil loss in Yellow River Basin mainly comes from the loose plateau, and the Yangtze River Basin mostly in the upstream. So we have different, shows different figures here, and the water erosion, this happens everywhere in China, and the wind erosion, like I just said, in the northwest China and also in the Mongolia, North China. And the sandstorms mostly come from the northwest China, and the gravity erosion distributed in the South China and the Loess Plateau. And for freezing and melting erosion distributed in the Tibet region with very high mountains. And here we classify the Chinese territory into different zones of soil erosion. So let's first look at, we have the Loess Plateau, very famous region related to soil erosion, and in the northwest China. And here is the upper Yangtze River and the southwest river area. And this is the northeast China, black soil zone, provide food, very good fertile soil, and is one of the major source of food production. And here is the Rocky Mountain area in North China, and here is the karst area in southwest China, and Rocky Mountains in southern China, and red soil in southern China, and sandy area. And afterwards, I will show the maps in different regions. Here you can see first, let's go to the Loess Plateau in China. This region, like the red circle, shows the Loess Plateau where it is located. And the Loess Plateau is located in the middle part of Yellow River, contributes 90% of sediment to the Yellow River. And it covers around 0.6 million square kilometers of the land of our Chinese territory. And the soil area is around 0.2 million square kilometers, around 30%, that means. The most serious area located in this region here, in the middle part. And it's covering an area of 78,000 square kilometers. You can see the landscape here. This is now the ecological, this is the terraced region. And here is the gullies with quite a lot of gullies. And here is vegetated grassland and also forestation. And here, the second zone is the upper Yangtze River and the southwest China. So this region, we have quite a lot of water resources. And also is the south border of China here. And the total area is about 1.7 million square kilometers. and with around 30% is eroded by soil, eroded regions. And the average annual loss was about 1.8 billion tons. So there are quite a lot of mountains and steep, dense population, steep land, and deep, dense population, small arable land in the slope land. So also here, the severe landslides and the debris flow is the environmental issues. You can see here the debris and also landslides cause the delta. So here is the northeast China. We have a very large area here. It's around, it's located in the northeast China with low mountains and long, gentle slopes, and the black soil layer, mollisols, is the dominant ground substance. The largest area, this is the largest area for food production in China. And around 20% of the total food production in China, mainly for soybeans, corn, are the primary crops. So, but the thing is that soil area is 0.2 million square kilometers, representing 30% of this area. You can see here, this is the cropland, and also with the gentle slopes, and here is also flooded area with crops. And the fourth zone is the Rocky Mountain area in North China here. You can see Beijing is here. So this is the mostly Rocky Mountain area. Beijing is crossed by the mountains and also close to the Bohai Sea. This area covers an area of 0.7 million square kilometers and close to Bohai Sea and hilly sub-regions. And the soil erosion area is 0.1 million square kilometers. It features with little soil. You can see here there are out of stones and rocks, but very thin soil coupled or in the rocks. So the soil layer and the cultivated land with the tillage layer thinner than 30 centimeters. So this region have very limited arable land. And also here, karst area in southwest China. This is very special in China because here you can see the corn was planted among the rocks. And this region, it's located in the southwest China. Have several different provinces like Guangzhou, Yunnan, and Guangxi, Sichuan, Chongqing. Has an area of 1 million square kilometers. And this region was featured by soil barren and serious stony desertification. You can see here. We have some terraces here, but some of them was desertified in the arable land. And the soil layer was less than 30 centimeters. This area accounted for 40%. And also we have some area for the red soil. The red soil was colored with red, so this region we call it red soil region. It's located in the downstream of Yangtze River and also in South China, close to the South China Sea. And we have several provinces here, and the total area is about 1.2 million square kilometers. And this type of soil is characterized by deep withering crust and very serious damage of clays. And it has a very hot and humid tropical climate and subtropical climate with high rainfall intensity. And you can see here we have very steep landforms and a very erodible soil rich material. So this area we have, if the gullies developed very well, so we have quite a high soil urine rates. The final one is the permafrost and glacier urine zone. This mostly in the Tibet Plateau. So mainly in the cold area of the alpine regions and with very limited human activities. And the eighth sandy area is mostly eroded by wind, mainly distributed in the deserts in the northwest of China and also in the Mongolia district. And it has continental climate and frequently affected by wind weather. And the wind days we have around for totally it's around 170 days for windy days. And this area covered 2.4 million square kilometers, and around 70% of the area was influenced by soil erosion. And the water erosion is only taking up 5%, and more than 20%, 80% region will have rainfall less than 200 millimeters. So only here we have around high rainfall, but in this region we have quite limited rainfall, maybe less than 50 millimeters. So the next is the degraded grassland. We have here, this close to the Inner Mongolia and also Tibet regions and also in northwest China. And here we can see mostly distributed in Inner Mongolia, Xinjiang, Qinghai, Tibet, and the wind erosion area. This may largely due to reclamation and overgrazing. And this one is belong to the urban area. So we have done quite a lot of constructions since in the last 30 or 40 years. We have the Chinese economy developed very fast, and also our construction works developed very rapidly. You can see here large-scale infrastructures like a bridge and the road and also railway. We have the construction of railway tunnels like here, and the soil loss was caused by urban development and constructions. And this is the different zones of Chinese soil erosion part. And the second part I would like to introduce the harms caused by severe erosion. It's including several parts. First is farmland and land degradation, farmland loss and land degradation, and also sedimentation, aggregate, flood, and water extraction, and low efficiency of water resources. So let's look at the first. In China, we have different regions eroded by different forces, like wind and water. And approximately 266 million hectares of farmland lost in the past 50 years. And 1 million square kilometer area was degraded in grassland, accounting for 50% of the total. And the annual increase is around 2,000 square kilometers with desertification. So in the last 20 years, the Chinese government has launched several large-scale projects to prevent this degradation and agricultural land loss. Here is also for the mollusc soil in the northeast China. You can see here the farming time. At the beginning, we have the black soil thickness around 1 meter. But after 70 years or 80 years, the soil loses around 70%. Now we have the black soil get quite a lot of soil erosion, and we lost quite a lot of black soil. And here we show the Yellow River, the Louis Plateau. This is where I am located. And you can see the rivers and also the delta because of the sediment discharged to the China Sea. According to the statistics and observations, we can see here the accumulated sediment deposited in the river, in the water storage projects like rivers and reservoirs reached more than 20 billion tons and accounting for more than 10% of the national reservoir capacity. So some of the reservoirs has lost its 10% of capacity. And also for this region, 1.6 billion tons of sediment from the Louis River discharged into the Yellow River, and 0.4 billion silted in the downstream of this region. And you can see here, I show one city. This is the tower in the downstream, and here is the riverbed and the water, Yellow River water. You can see the water level is higher than the ground. So this is due to the riverbed sedimentation. And also in each year, 20 million hectares of farmland suffered from drought and mainly in the soil area. And also 60% to 75% of rainfall water lost because of soil in the Yellow River. And also we have very high pollutions, and this is 20 years ago, but now it's becoming better. And the soil on the sloping farmland carries large amounts of nutrients, pesticide, and fertilizer residues into rivers, lakes, and reservoirs, forming 9-point source pollution and affecting water quality of lakes. And also the nitrogen and phosphorus loss in the residues in the urban area are important pollution source to the freshwater bodies. You can see here, in the South China, I think in 1990s, there are some large lakes with algae blooming. So, but now it's becoming very good now because the Chinese government noticed not only the economy development is important, but also fresh water and eco-environment is also one important issue for the human beings. And this is the rocky area and also desertifications in the grassland. So from 1970 to 2000, this period, we have the soil desertification developed very fast, but afterwards it's becoming better. And here you see, we show the land degradation, loss of land source, and crop reductions, and also frequent sandstorms. And these figures show what happened this year. So this is the rainfall distribution in China for one day. Extreme storms in July 21st this year in Zhengzhou, very large cities. In the center of the rainfall, we have around 600 millimeters. So you can see the urban area was flooded and also caused quite a lot of muddy and soil distributed along the street. And also the cars was flooded and with quite a lot of economy loss. So large floods and urine disaster risk to agricultural production, also to the urban area, and the death of inhabitants and influencing normal life. And also damages could lead to city transportation, hydraulics, and electricity disruption. And also due to the soil erosion, and it may lead to the land degradation and storms. So the soil layer becomes thinner and the soil fertility decreases. So the poverty may intensify. And more than 90% of Chinese poor people live in area with serious erosion region. And here we show some figures that was overgrazing and man-made soil erosion with constructions, and also with overlogging and farming on the steep slopes. So in the second part, I mainly introduce the soil erosion types and the soil erosion distribution in China. And now in the third part, I would like to introduce the achievements and experience of our country. So first is the strategy of soil and water conservation in China. And the Chinese government divided China, according to soil urine types, into 8 regions and 41 sub-regions for soil and water conservation. And the first is black soil regions in northeast China, and the windy and sandy area in northern China, and the earth rocky mountains here, this region, and the Lewis Plateau in the middle part of the Yellow River, and the red soil regions in the south part of China, and the purple soil in the middle of China, in the middle South China, and the coastal regions here in southeast China. And also the final one is the Tibet Plateau region. So you can see here, first is for the black soil region in the northeast China. The main issue in this region is the soil layer of cropland vary between 20 to 40 centimeters, and soil rate increasing. So the driving force is erosive rainfall, and with long hill slopes and erodible black soil. So you can see here, this is the typical scheme for soil and water conservation. The main measures including forest in the top hills, and also with the economy forest, like OTROS or some other apple trees or pears. And for the gullies here, we have the gully head protections and check dams here in the bottom of the hill. And also here we have, in the long hill slopes, we built terraces and trenches to protect the soil. And also we have vegetation belt in here and also in the uphill. So the key technology I have already introduced, and also the performance is the achievements. We want to decrease the soil urine by 70%, and farmers' income increasing very fast. And for the windy and sandy regions, this is the annual general features of the windy and sandy regions. And we have different kind of conservation practices. As you can see here, due to the limited rainfall, we have irrigation systems. And also for the oasis area, we have irrigation kernel. And to protect the urban area, we have planting quite a lot of trees and also grassland with a different belt. And also we provide deep water irrigation, and also we have some power supply from the sunlight. This is a clean energy generation in the desert, close to desert regions. And this is the typical scheme for windy and sandy region. If we have oasis agriculture, then we have to the main issue is the wind erosion and then grassland degradation and land desertification. And the main objective is to restore the degraded land and to establish shelter bed networks to prevent land desertification. And we have the key technology with water irrigation and artificial grassland and farmland shelter belt for afforestation. So the main achievement is to reduce the wind erosion and to improve the income and also to improve the grassland quality. And for the desert oasis, we have the main issue is the serious desertification. And we want to prevent wind erosion by establishing physical and vegetative sand fixing belts. And here the main technology is the grassland and the straw squares, and also brackish water dissemination. And the final achievement is here. So for the Rocky Mountains here, this area is with very large cities, but the dominant soil urine type is water urine, and the sloping farmland are the main water urine area. So the combination of steep slopes and frequent intensive rainfall is the main reason for the soil urine. So we here have different schemes, and the key technology is for closing or the banning the natural grassland for grazing, and also including ecological restoration. And also for farming land, we have terraces and forest shelter beds. So the final result the aim is to reduce soil urine 75% and to increase the agricultural productivity by 40%. And here, this is the Lewis Plateau. The main issue is the serious soil urine and very vulnerable ecosystems. And here you can see, due to the sediment transportation to the Yellow River, and we can see the river delta change very fast. You can see here in 1973, we have here, this is the river delta, sorry. And here in 2016, we have the river delta here. So after the Chinese government treatment, the runoff and sediment load reduced 90%. And now the sediment balance between riverbed sedimentation and delta shrink should be resolved. And the main scheme is including two parts. One is for ecological restoration, and one is for agricultural farming. And the key technology is for this one is vegetation restoration, and this area is also our free project area. So the soil urine rate can reduce from 14,000 to around 1,000. And in the agricultural regions, we have terraces and runoff collection structures, and also drainage and diversion on tablelands and gully controls. So the check dams and also some other engineering practices are the main practices. We control the gullies to reduce 20% of runoff and to reduce the sediment yield. And for the south part of the red soil regions, we have a special treatment with the whole horizon trench in the upper part to distribute the upstream runoff, and also using the slope cutting and the vegetation zone and the check dams to prevent the landslides and also the soil erosion to transport downstream. So we have different check dam systems and vegetation combination to prevent the soil erosion and the transport. This is the different schemes for the conservation. One is for agriculture ecosystems, and one is for gully control system. So for the agricultural system, it's for biozone utilization of water and biogas disaster. And for the gully control, we have vegetation and the trenches and also check dams. And for the purple soil zone, you can see here, this is quite a lot of terraces here. And also we got some holes here that was used for collecting the water. And here you can see this is the ditches to collecting the water, and also to divert the water from the top slope to the bottom. That was made used for irrigation, and also to be making use of the water, not to flood it or to flush the surface soil. This is for the two different schemes. For the one is from terrace small catchment management in the surface water system, and one is for the based on the field bounds and plant high growth. So this is a different control system. And another one is very special here. You can see that from the middle part of this figure, you see here, the rainfall comes from the sky, and the rainfall can fall down, and then it can infiltrate from the soil, and then become the ground river in the karst river zone. So water erosion and karst rocky desertification are the dominant soil area. This area is characterized by high density and with soluble carbonate rocks, a shallow and broken soil layer. The rainfall can come through the heavy bedrocks fractures and form the underground river systems. So here we have different structures for using forestation and reservoirs and water lifting for irrigation and deep well pumping, and to different orchards, grassland distribution and farming for different agricultural systems. So due to the time, I think I would skip some of the main achievements and experience. So since 1949, the new Chinese government began to attach great importance to soil and water conservation, and a steady decline in soil erosion rates monitored from 1985 to 2018. And compare with this is 2000 erosion map, this is 2015. So we see that the Chinese soil erosion area decreased 77% in 2018. You can see here, this is the terraced orchard, tea orchard, and here is the forested area. And also we get different laws for soil and water conservation, and they get good results for soil erosion control. And here you see here, the Chinese government launched large-scale projects for soil conservation, and including this black soil erosion control, Beijing water resource management, Taihang mountain soil conservation, and Louis Plateau soil and water conservation, and grassland conservation in the northern part, and also soil conservation in the southern part of China. Here you see that this is the different projects for the landscape. You can see here, this is the conservation in the upstream of the Yangtze River. And this is the desertification control around the Chinese capital, but it's far away. And also in the middle part of the Yellow River, it's becoming green with quite a lot of vegetation restoration. Here is for the slope farmland, we have converted to the forest. And we also have some other water resource management practices. And we have quite different conservation projects implemented in different regions, especially in the river source area, Yangtze, Yellow River, and Lancang rivers. And also for the two grazing control projects implemented in around 900 countries. And also we implemented the soil and water conservation laws in different regions, and with quite a lot with various engineering projects. And we also enhance or improve the scientific research, such as we use modern technologies for research, and also to build quite a lot of. These are numerous monitoring stations we built for soil erosion monitoring. And this is the on-site station monitoring. And here shows the different runoff plots. And finally, we also have the academic exchange with, this is the International Soil Conservation Symposium. And also we have cooperation with Netherlands. We have cooperation with with the clique from Austria, and also Peter is not here. And also here we have a meeting in Nanjing, and also the King of Netherlands come to China to visit us. And finally, around 10 minutes, I would like to introduce our study on the Louis Plateau. It's a very simple results. So first, I would like to introduce the ecological restoration concept. So it is to get to accelerate the natural evolution through artificial methods in area where the ecosystem have been slightly moderately damaged or degraded land. And this is mainly according to the principles of soil and water conservation and restoration ecology, and including artificial afforestation and grassing, and also self-restoration of ecosystems. And here is for the Chinese different regions for ecological protection, like garlic controls and terracing, and water conservation, forestation, wetland vegetations, and soil and water conservation in different for the hills, and also grass planting and plain ecological shelter forestation. And for the technology, we have many terraces, slope treatment here, and ditch treatment with the channels to protect the rivers. And so the Louis Plateau is our main research area. I'm here, close to Xi'an, and the Louis Plateau has around 0.6 million square kilometer, and it's the largest Louis soil cover area, with thickness of Louis soil around 50 meter to 300 meter. And in the middle reaches of the Yellow River contribute 90% of the sediment load, but the relative light water resources. And in this area, it's breeding 12% of people of China and providing 15% of water used for farmland, and contribute 14% grocery domestic production. You can see here, these figures shows 40 years ago. But now I would also may show the figures here. So this slide generally introduced the soil, the Louis soil has the higher shear strength and pressure resistance, and made of quartz. Is the homogeneous and vertical and very strong natures here. You can, but with very easily to collapse. These figures, I made it, and I made it because I want to show the history of changes on the Louis Plateau. This is the soil urine rate. So around 4,000 years ago, soil urine rates are really low, but afterwards, so the human activities here, the blue dots are the human activity, the population numbers. You can see in the last one century, population increased very fast. So also the soil urine rates increased very fast. And here I compare with the soil urine and also sediment load in the rivers. So the Louis Plateau experienced very cold and dry period in the early Holocene here, and a warm and wet period in the middle Holocene. Soil urine rates were very low in that period, but it increased to around 1.0 to 1.2 gigabyte chan, and then this was due to enhanced increasing cultivation and deforestation. But now, so we have the history. We also introduced here in the last century, the Chinese government tried to reduce the soil erosion. And the main measures including ditches and terraces. And in the 1980s, we have check dams and terraces and protected the tableland, slope, and also fixed the ditch. And in 1990s, we have Green for Green. This is a large project for afforestation, and also grazing prohibition and garlic controls. And after 2000 or 2020, we have beautiful countryside program and also industrial or urbanization sprawl. So that was for ecological to move the farmers to the cities, and then the arable land the slope arable land could be converted to afforestation and to grassland. So after 70 years conservation, we here shows different practices. You can see the Lewis Plateau has around quite a lot of terraces here, and also check dams in the very serious eroded area, and also the reservoirs here. So the reduction of soil erosion and sediment show consistency with the implementation of soil and water conservation practices. So this is 14 years ago, and this is 14 years afterwards. And this is before treatment. This is now the current status of small watershed. Okay, so we still have 7 minutes, maybe. And here we show the annual changes of the vegetation. You can see here, the green part become 2000 the NDVI in 18. Trends of the NDVI changes, you can see here, the vegetation cover increased from 30% to 60%. And also we show the sedimentation and the runoff changes. So you can see here, from 1999 to 2009 here, you can see here, we have the runoff and the sedimentation decreased, but sedimentation decreased higher than the runoff reduction. But here we also shows the runoff changes and also the sedimentation changes. So we have quite a lot, we have a number of hydrological stations here. The mainly come from this middle part of the rivers. And then now the colors, now it's reduced significantly. So due to the time, I think I would not introduce much about the response of soil properties changes to afforestation. And this may shows the soil erosion modeling works. So in January, we can see that the soil erosion reduced from 2000 to 2018. And also it has afforestation can sequester the soil organic carbon. And also the Lewis Plateau, the economy was increased. You can see here, the income increased more than 10 times in 2015, now it's around 43,000 yuan. So a short summary, and so in China, serious soil related to various land degradation in different parts of China. And also Chinese government launched numerous projects to improve ecological environment and reduce soil erosion and sediment to the rivers. And different conservation measures were developed due to specific climate and topography and soil types. And I think the Chinese government will continue to further do the ecological restorations by implementing different conservations and water resource management practices. So thank you very much for your attention. I'm sorry for that we can't do a face-to-face presentation that may spend 1 hour. That may be a little boring because always I'm talking and some of you never speak during the time. And this figure shows our project meeting. I hope I think we build a good friendship, and we are looking for further and future successful cooperation. And thanks again for Professor Gómez to give a chance to introduce the Chinese soil erosion patterns and conservation experience. So, okay, that's all for all my presentation.
Thanks so much, Guangju. Thanks for your effort. It has not been boring. It has been really interesting. To keep the program, there is time for one or two quick questions. Hassan, why don't you come here and do that, because otherwise it's going to be complicated with the microphone. So
okay,
you are going to have, he's coming to the microphone. So he, just put here and do it.
Hello, Mr. Zhao. Thank you for your wonderful presentation and the insightful of the Lost Plateau. And I'm wondering that you have given so many examples of the Lost Plateau. And I was curious to know about that. The Gobi Desert is also lies in the Lost Plateau, and the wind erosion is a major major cause of soil erosion in that area. Is there any kind of activities and the practices ongoing to protect that area in the Lost Plateau?
Yes, we have quite a lot of conservation measures here, like check dams and terraces for water erosion. Also, we have 20 years of forestation and grazing prohibition to protect the windy erosion area. And also, due to the Chinese economy developing, there are quite a lot of farmers who went to the cities. So some of the hill slope arable land was quit, and the farmers didn't tillage the slope land. And then now, after 20 years, the slope lands was protected by the grass and forestation. That's why the soil erosion rates decreased very fast.
Okay, thank you. Another part. You mentioned that the Lost Plateau that lies in the Shanxi and the Shanxi province, and as far as I understand, this is the biggest area that has mineral resources, and there is open pit mining ongoing on that area. Do you think the open pit mining has some impact on the soil erosion, and especially from the wind and the thunderstorms?
Yeah, good question. Apparently, I think the mining activity could lead to some erosion, like wind erosion and also water erosion. But the Chinese law now, it has launched 20 years ago. In 1998, I think, the soil and water conservation laws was launched. So if any activities such as railway stations, railway construction, or any buildings was constructed, then they have to first to do the soil and water conservation to protect the soils. Otherwise, they are not allowed to do the mining. So I think if they have some protection practices to protect the soils that was digged outside. But if there are really large storms, they may increase. They can't prevent the water erosion. But the soil erosion, I think there's no problem because they can cover it with some grass and also with different plastic things temporarily.
Thank you for your answer.
Okay, thanks so much, Guangju. Hopefully next time we'll meet in person. And now we are shutting
Yeah.
down the connection. Thanks again.
Yeah, no problem. Okay.
And
Yeah.
enjoy the rest of the day. Bye-bye. Cheers.
Okay, thank you very much.
Okay.
Okay, bye.
Bye.